Hello learners, welcome back to my channel Shraddha's Physics. Today we will start the Boolean Algebra. So it was developed by George Boole. Okay, George Boole. That's why after him this name comes, that is Boolean Algebra. So it helps in the digital circuit, or we can say that it was developed by the George Boole by the help of switches, or that switches is called the relay circuits. This Boolean algebra, it was developed by on the basis of the three theorem. First of all, NOT theorem, we will see in detail. It is based on this Boolean algebra. It is based on the three theorems. One is NOT theorem, second is AND theorem, and the third one is OR theorem. So basing on these three concepts, we will discuss furthermore. So first of all, see the NOT theorem. So NOT theorem means when we will give the input to be 1, then because of the presence of this NOT gate, it will goes to 0. I think you can remember this is your NOT gate. I am not going in detail in that. So and also if I will give 0 to the NOT gate, then the output will remain 1. This is your input and this will be your output. It means that if you will just give 1, you will get the just opposite of that. If you will give 0, then the output will be 1. It means that if you will give a signal A, then you will get A bar. This is A bar, or it is simply called A prime. Okay. And also if you will give A, then you will get A bar, and you should remember that if you will give A bar, then you will get A. It means that you are getting A bar of A bar. Okay. If you will give A, then you will get A bar. Then if you will give A bar, then you will get A bar of bar. So this is nothing but A. That's why we are writing A bar of bar or A prime of prime, that is equal to A. This is the NOT theorem. Now we will see AND theorem. You can remember the AND gate, that is, suppose these are the two input, one terminal is A and other is B, and you will get the output as Y, that is equal to A into B. I am not writing exactly the truth table, etc. I have already uploaded this symbol of AND gate and the symbols in my short videos, so you can see from there. So in AND theorem, it is simply represented by dot A dot B. We are writing A dot B. This dot represents the AND gate, and if you will put 0 and 0, if you will put A terminal as 0 and B terminal as 0, then 0 into 0 you will get 0. If you will give A terminal to be 0, B terminal to be 1, then you will get 0 into 1, it is also 0. If I will give 1 to the input terminal A and 0 to the terminal B, then also you will get 0. If I will give the both terminals high, then you will get 1. So it means that in the AND operation, when both the terminals are in the on state or in the on state, and we can say that this is in the high state, then you will get the output. Otherwise you will not get any output. Simply we can write this as 0 into A, that will be equal to 0, because A means here it may be 0, it may be 1. So you can see that whether it may be 0 or it may be 1, the output will remain as 0. Now if my input 1 into, I will write A, then what will happen? This is equal to, it depends on A, because if I will put A to be 0, suppose A is 0, then this is nothing but A equal to 0, 1 into 0 is 0. If we will put A to be 1, then 1 into 1, this will becomes 1. That is why we are writing 1 into A, that is equal to A. Similarly, A into A, what will be the value of A into A? So A into A is nothing but A, because if we will put 1 here and 1 here, you will get 1. If we will put 0 into 0, also you will get 0. It means that A into A, it will depends on the value of A. A into A bar, A into A bar means if A is 1, A bar is 0, or if A is 0, then A bar is 1, then it will always give 0. Okay. So let me write in a clear way. Try to make a note of your own. Now we will see OR theorem. So in the OR theorem means it is simply addition symbol. Okay. And you know the gate for it, the symbol for it is, this is the symbol for the OR gate. This is A and B are the input terminal and Y is the output terminal, and that is equal to A plus B. Okay. Now we will see the operation, that is in the A terminal and in the B terminal what will give, suppose 0 0, both are in the off state. Then you will, if we will add these two, what will get, 0 plus 0 is 0. Suppose A is 0, B is 1, 1 plus 0 is 1. Suppose A is on state and B is off state, then that will be also 1. If both are in the on state, 1 plus 1, it also gives your 1. So in the OR state, or you can say that in OR gate operation, you can see that whether the single input is high or both the inputs are remain high, then you will get the output terminal to be high. Or if both the input terminals are in the low state, then you will get the low output or the output is 0. Similarly, we can write 0 plus A. 0 plus A means if we will put A to be 0, then 0 plus 0 is 0, and 0 if we will put A to be 1, then 0 plus 1 equal to 1. So here you can see that if I will change the value of A, then here you can see that the output will be changed, that is it remains as A. 1 plus A means you have to put first 0, if 1 plus 0 then 1, and also 1 plus A, that is if A equal to 1 then also you will get 1, that is why 1 plus A equal to 1, and A plus A, this is equal to A and A plus A bar, you can check by yourself, A plus A bar that is equal to 1. Okay. This is your OR theorem. Now let us see the distributive theorem. Suppose I am considering that output is given y equal to suppose A plus B into A plus B dot A plus C, that is the AND, A plus B into A plus C. So that will becomes, you can write A into A, so this is A into A, then plus A into C plus A dot C, similarly plus B dot A and plus B dot C we can write. If I will solve this, you know A into A or A dot A, it is equal to A plus A dot C is nothing but AC, B dot A is nothing but AB, and B dot C we can write it as B into C, that is BC. If I will take common from these three terms, that is if I will take common A, then this will be 1 plus C plus B from these three terms, and the remaining term is BC. You can see that if I will add, whether C may be 0, B may be 0, or you may put B or C to be 0, 1 and so on, you will always get 1, because when one terminal of the OR gate is 1 or in the high state, then you will get always in the high output. So I can write it as A into 1 plus BC, or this is simply equal to A plus BC. So it means that this is actually you are using as your trick to solve some problems. You can see here the first term, this A plus BC means here I just write A plus B dot A plus C, this is equal to A plus BC. You can see that this first term and here this first term, they are same. When these two terms remain same, you can simply write it as A plus BC. When the two brackets are available and the first term of the both the brackets are same, then we apply this distributive theorem, that is A plus B into A plus C equal to A plus BC. Clear? Or if you will give A plus BC, then you just come to this, that is A plus B into A plus C. So, this is our final result. Now, let us take some examples. Minimize the expression, that is, the expression is this given y equal to, suppose, a plus b into a plus b bar into a bar plus b into a bar plus b bar. Just try to solve by yourself. So, this will be equal to, you can write from this, try to multiply this 2 term and try to multiply this 2 term. Why? Because you can see that this, the bracketed term of the first term is a, and in this second bracketed term it also contains a, and the third and fourth term it contains a bar. That is why I am taking common from these 2 term individually and this 2 term individually. So, taking this 2 term a plus b into a plus b bar, we can write it as a plus we can write a plus b into b bar, because from our formula we know, here you can see that a plus b into a plus c equal to a plus bc. Here in our question it is given a plus b into a plus b bar. That is why this is, suppose 1 plus 2 into 1 plus 3, we are writing it as 1 plus 2 into 3. Okay, this is your 1 into 2, 1 into 3. So, this is simply a plus b into b bar, because in place of c it is b bar. That is why we are writing 1 a plus b into b bar. Okay. Similarly, in this third and fourth term we can combinedly write it as, this will be a bar taking common, this will be a bar plus this is your b into b bar. So, b into b bar, that will be equal to, you know, when we are multiplying, when you are multiplying with b into b bar, it means that one is 0, other is 1. If any of the input is 0, then in the AND operation you will get 0. Since this is a conjugate of other, you will definitely get a 0. That is why this term goes to 0. You will get a into, first I am writing a plus 0 into, this is your a bar plus 0, which is equal to a into a bar. So, what is the value of a into a bar? Similarly, this is also equal to 0. Okay. You have, when you are giving that minimize the expression means you have to put this formula or this expression to solve. Let us take another example. Suppose the same, it is also given to minimize the expression y equal to b plus, this is y equal to b plus b bar into c. Here b plus b bar into c. So, it means that it is given in the form of, suppose I am writing it first, a plus b into a plus c, it is equal to a plus bc. So, here you can see that a plus bc is given. So, you have to write in the form of this, that is a plus b into a plus c form. So, what you have to write? This will be 1 plus 2 into 3, that is equal to, I have already told, 1 plus 2 into 1 plus 3, this is in this form. So, 1 plus 2 means here, this b is 1 and this is your 2 into 3, 1 into 2 means b plus b bar, and 1 plus 3 means b plus c. Clear? So, b plus b bar means here, b plus b bar means if one is 0, other is 1, and if one is, first one is a, or this is I am writing for b and b bar. If b is 1, b bar is 0. So, in this case, if any of the input is high, we will always get 1. So, b plus b bar will be always equal to b. Sorry, it is 1. B plus b bar is always 1 into b plus c. So, this will be equal to b plus c. So, this is your minimized expression. Let us take one more example. Suppose y equal to, it is given a bar b bar c plus a bar b c bar plus a bar b into c plus a b c. You have to minimize this expression. here you have to minimize the expression. I am not writing here always minimize, you have to just minimize the expression. So, this will be equal to, so first of all you must keep in your mind that what term you can take the common mostly. So, here you can see that in this third and fourth term you can take the common BC, so that you will get a bar plus a, you know a bar plus a is 1. So, that is why it should be in your mind what you have to take the common. So, the first term is remain as it is, a bar b bar c plus a bar b c bar, and here we have taken common BC, that is why it is a bar plus a bar plus a, this term goes to 1, and that is why it will be equal to a bar b bar c plus a bar b c bar plus BC. Now, from the second and third term, if we will take the common b, then this will becomes a bar, the first term remain as it is, a bar b bar c plus taking common b, you will get c plus a bar into c bar. Now, this is in the form of 1 plus 2 into 3. So, that will be equal to a bar b bar c plus b whole into, this will be 1, that is c plus a bar 1 plus 2 into 1 plus 3, that is c plus c bar. This is our formula. Now, this will become c plus a bar into c plus c bar, this c plus c bar is again 1. So, you will get this is equal to a bar b bar c plus, this will be b, multiplying this b into c plus a bar, you will get bc plus b into a bar. Now, taking c common from this term, this will be equal to, c taking common, this will be a bar b bar plus b, and this will be plus b a bar, or this is your a bar b. Now, this term will be equal to, now also you can see that this is also in the form of 1 plus 2 into 3, this is 2 into 3, this is your 1. Now, if you will split this, you can write it here, I am writing, this will be equal to c whole into the first term, that is 1 into 2. So, we can write it as b plus a bar into here 1 into 3, that will be b plus, sorry 1 plus 3, that is b plus b bar, and the last term remains as it is, that is plus b into a bar. If we will see this b plus b bar, it will give 1, okay, b plus b bar, it will give 1. So, the remaining term will be equal to, if I will multiply this term, see here, this will be bc plus a bar b plus b a bar or a bar b, sorry I am written it by mistakenly. So, this will be a bar c, if I will multiply c here, a bar c plus this term b into a bar, okay. So, this is our minimized expression. So, you can see that this is our given condition, and we have reduced it to bc plus a bar c plus b into a bar, or this is your simply a bar b. I am giving you some homework question, one homework question, that is y equal to a plus b plus c whole into a plus b plus c bar into a plus b bar plus c, okay. You have to solve it, or you can say that you have to minimize this expression, minimize, okay. Here I am just telling you that just try to put here x equal to, you have to take a plus b, then try to solve this, you can solve it quickly, give your answer in the comment section. So, this is all for today. If you like the videos, you can share and subscribe to my channel. Thank you.